Hello, my name is Tarik Kirkendoll, and this is my Module 2 exam report. Uh, I am using a version of Excel online because Excel doesn't work for me on terms of like as a desktop app. So I made all this like at the college, but while making the video, I needed a microphone, so I'm using my laptop. So I don't have all the same features available, and I've Googled as much as I could have to fix this, but I can't show you the formulas all at once, but I'll try clicking on them as I go. Okay, so for question 1, that's talked about uh, interview or survey about government bailout money and what people's responses were to that question. So like out of everybody who you asked, which was 1,000 people, and you looked for everybody that said no, that would be 500 out of 1,000, which is when reduced is half, and then basically 50%. But when you did P, no, or probability of women that said no, you're just looking for women. So that's basically if you were walking down the street and you only asked women what their opinion was. So therefore, it's not going to be out of 1,000, it's going to be out of 500. So I took the number that said no, so which is 215, reduced it, got 3 out of 7, and then I got 43%. For men, I ended up with the same number when I added together men who said yes and not sure. I got 215 again, and I got the same information. So yes. For question number 2, which was the 2 dice, I took the original question was like, find the sum of certain numbers and primes of other numbers and how often do they appear. So I made these sample spaces. I made 4. I know that this one coincides with the first one, and this one correlates with the second, this one with the third and the fourth. I think I have them a little backwards, but I took the information from that, counted. So if I got like 4 out of 36, I would reduce it and then put it into a decimal and then put the percent to a fraction. Or put a percent to the 10th place. I thought you could use this information, or basically for any kind of gambling. I don't fully understand how gambling works, but if you need a certain roll, you know the likelihood or the likelihood of getting that certain roll. So if like, I know snake eyes is the term, I think it's bad, but if like your odds of getting a snake eye would probably be 1 out of 36. So for number 3, which was the lottery question, I listed out all the information below, and then I just basically plugged in what it said. So 1 out of 14 for this, 1 out of 14 for that, and then the outcome of that. I know this outcome is 0 because you basically got back the money that you spent, and then this one's -5 because you didn't get any money from your lottery ticket, which was the most likely scenario in the lottery. But to get the expected outcome, I did multiply the probability decimal by the outcome, and then I just did the black cross thinking and going all the way down, and I double checked the information, so it should be correct. The data that was listed originally was not odds because it didn't compare it to the unfavorable outcomes. So I guess they described it incorrectly. It's really just generic probability by saying your odds of winning are 1 in 14, or the probability of you 1 in 14, when that would, in actuality, if it were odds, be 1 out of 13. So for question number 4, when you were finding the odds against an event with a certain probability, so probability of B equals 9 over 13, so you had to display the information. Well, first you have to get the odds. So I did do the equal sign to calculate this. I got, for the odds in favor, you put the outcomes that you want. So 9 would go before the 4. And then I got 225%, which you said if anything goes over 100%, that means it's just twice as likely to happen. And then I flipped it because if you want the odds against, which is your negative outcomes first, it would be 4 out of 9. And if you divided that, it would be 0.400 or 444. Yes. And then you would put it into percent, it would be 44.4%. If you showed it in a diagram, I used hearts for no actual reason other than I wanted to use hearts. For the odds in favor, they would be on the left because it's your outcomes that you want. There's 9. The unfavored outcomes with 4. And then unfavored outcomes for odds against, that's wrong, but it would be first and then it would be the other one. In the chart, it clearly demonstrates that the odds in favor were much superior to the odds against. For question number 5, which pertains to the women in the military, where we had to draw or had to create a diagram that represented that information. We started off with pretty much just the total, a number of people in the military, and then the percent of women out of that total. So using that information, we were able to extrapolate the total number of women, because you basically subtract it from the number of men once you figured out the number of men, and then the percent of men, and then the total men. When you demonstrate this information into a graph, or demonstrate, but you display it as a graph, you can't really see it in this, but it's there. Like, the percent of women when I was making the graph did appear, and it is very short and small, and it's like just so close to 0% once I turned that into a graph. Here, let me click on the formula so you know that I did them. Yeah. Okay. Yeah, based on the graph, you can clearly tell or determine the number of women over the, or number of men over the number of women in terms of who all was in the military. So number 6, which was where we had to explain a binomial experiment, and it's an experiment that consists of n repeated trials. Each trial can result in 2 possible outcomes. We call one of these outcomes a success, the other a failure. The probability of success denoted by P is the same by every trial. So when making the sample space, we could only really have 2 possible outcomes, so the sample space was going to be fairly small. Here I listed the 3 main types of the 3 formulas, and then did the formulas and got these answers. And for the first one, I did combine and then typed in a lot of information from a lot of cells, mainly these 4 back again. I copy and pasted that as a percentage and then pressed the percent key and then got that. And yes, that is my whole probability experiment. Or not probability experiment, but my whole exam. Thank you.